with n equals 4 or 4 intervals return to 4 rectangles, we can manage those computations. But let's just say that if we want to estimate the area under the curve using 100 rectangles, 1000 rectangles for example, because the more rectangles we use, the better the estimate. The better estimate, the less error. The lesser error, the more exact the approximation will be. But it is almost a daunting task to have to add 100 terms, 1000 terms. And let's assume for a moment that we do not have access to a calculator that gives us the integral notation. Many of you do. We know from the definition of the definite integral, the integral from a to b of f of x dx is the limits at n go to infinity of the sum as I go from 1 to n f of xi times delta x. This is called the Riemann sum. To set up this Riemann sum, we would need to know what xi is and delta x. Delta x is always b minus a over n, where b and a are limits of integration given in the definite integral. X naught is always a, the lower limit of integration. The increment is delta x, so x1 is a plus 1 delta x, x2 is a plus 2 delta x, x3 is a plus 3 delta x. So xi is a plus I delta x, but delta x is b minus a over n. X sub n should be b. That is, xi is a plus I delta x, where delta x is b minus a over n. If we were to use the left sum, then we use the height on the left-hand side of the first subinterval, the height on the left-hand side of the second subinterval, and the height on the left-hand side of the last subinterval. The left sum is the sum at I go from 0 to n minus 1 of f of xi times delta x, where f of xi is f of a plus I delta x. If we use the right sum, then we use the height on the right endpoint of the first interval, the right endpoint of the second interval, and the height on the right endpoint of the last interval. The right sum is therefore the sum at I go from 1 to n f of xi times delta x. This is the same formula at the left sum, but we start at I equals 1 and end with n. We still have n terms in the sum. N terms in the sum.